Welcome back. We are going to analyze problems for section 1.5, and this is the first problem. It says that a business manager determined that T month after production begins on a new product, the number of units P, or maybe N of T, the number of units at the time T. So N of 1 will be the number of units produced after 1 month in thousand. N of 5 will be the number of units produced after 5 months in thousand. So he predict that the number of units that he produced after T month will be 6 times T squared plus 5T divided by T plus 1 squared. And it says when T approach to infinity, what is the number of items that he will produce? Well, when T approaches, this is a classical problem of limits, so we have to find the limit when T goes to infinity of the function N of T. So this is the limit when T goes to infinity of the function 6T squared plus 5T divided by T plus 1 squared. As I have said, there are three ways of performing this limit. The first way is a visual way, is to draw the function. The second way is to plug in numbers. If you plug a big number because T goes to infinity, you plug, for example, 1,000,000 10 to the 6 square plus 5 times 10 to the 6 divided by 10 to the 6 plus 1 squared, to what it will go, this number? It will go to approximately the number 6. So 6,000 will be produced after T goes to infinity. Okay, so now let's go to calculate. To calculate this limit is the limit when T goes to infinity of 6T squared plus 5T divided by T plus 1. T plus 1 squared is T squared plus 1 squared plus 2T. So to do this limit, we do the limit like this. Limit when T goes to infinity. We divide by T squared the numerator and the denominator. So we divide every term by T squared in a way that now we can say what happened when T goes to infinity. Divide by T squared, divide by T squared. Now, this would be the limit when T goes to infinity of T of 6 plus 5 divided by T divided by T squared divided by T squared. This is 1 plus 1 divided by T squared plus 2 divided by T, because 2T divided by T squared is 2 divided by T. Okay, 2 divided by T. So as T goes to infinity, this term goes to 0. This term goes to 0 because 1 divided by a big number goes to 0. 5 divided by a big number goes to 0. So the limit goes to 6. The other thing that you can do is you can go to GeoGebra and you can plug in this function. In GeoGebra, you can plug in the function input. Let me see if I can do it here. Let me see, maybe I can do it. Browser, you go to GeoGebra, graph. GeoGebra graph, let's go to see. Graphing calculator, GeoGebra. So you go here, recover. I have done this function before, so I have recovered So this is the function that I have plugged in. You see when x equal minus 1 goes to infinity, but when x goes to the infinity, the function approach to 6. If you go to the infinity, the function approach to 6 as x goes to the infinity. So you can go very, very far, and the 6 will be a rectilinear line. Y equals 6 will be a rectilinear line like this one. Let me see if I can draw this line. This is the 5. The 6 is an horizontal line. You see, it goes through here, 6, 6, have the height 6, and the function is approaching 6 as x goes to infinity. In this case, the x is the t. So we have solved this problem. Let's go to the next problem. The next problem say, I think that I did in another video this problem, maybe, but this is Alicia de Manera of Lang. He say, you can say what is the cost function when x equal 80%. When x equal 80, well, you plug in the numbers. 8 by 80 squared minus 63.6 multiplied by 80. So when this is the cost function. What is the cost when you are producing 80, when you are at the level of production of 80%? Minus 320 divided by 80 squared minus 68 by 80 minus 960. So you do the number and you will find the cost that the factory will have when the factory is producing only 80%. If the factory is producing at 100%, this cost should be smaller, I suppose. Okay, that's the two problems for section 1.5.